Hello everyone, my name is Ridham Balik and you're watching Balik Robotics. In today's video, we are going to touch a new topic which is optimizers in deep learning. So, in this video, we are going to see how a neural network actually reduce the loss. So, without wasting much time, let's jump to the video. Okay, so let's start. We have seen in the previous videos that this is how our neural network work. Like we have input data, then our loss function give the loss or error, and then we have some optimization method which then fix the loss and make our model more accurate. So let's see how we can do this. So we already know that our neural network consists of different weights and some bias. Okay, and our input will has multiplied with the weights, and then we have a summation of these, and then we get some result. Okay, so uh, now for the it's like what our optimization does is like it use a gradient. So what is gradient? Gradient is a curve. Okay, so this is a gradient descent. What it does, it make a curve which is weight and a loss graph. So let's say this is our weight. So here it is, and the loss graph is going in this way. So what our gradient descent does, it just only is like increment or decrement the weights and try to find the optimal weight. Like here we have minimal loss. So this is our perfect weight. So our gradient descent, what it does keep on adding in the training like this, and then we get our minimum weight or minimal loss. So gradient, what is gradient? Slope of the loss function with respect of parameter, means this loss function with the weight. So here this is a minimal, here also loss increases, here also loss increases, we have to reach there. Okay, so if the loss slope is positive, then we will decrease the weight, and if it's negative, then we will increase the weight. We just have to come in the center, like optimal minimal center. So this this is a gradient descent. This tell the optimizer in which direction we have to move our weight, increase or decrease, so that we have a like minimum error. Okay, now we have some learning rate also in the optimizers. We have two things, like one is gradient and second is learning rate. Learning rate is like it tells that how much fast, like how much bigger the addition or subtraction is done. Like here, if the learning rate is too low, then it will like increase something, then plus, then again increase, then again, like this will very slower, like it will take much epoch, many epoch than this one. In this, there's a moderate amount of learning rate. Here, it exponentially increase by that learning rate, and it will reach the minimal weight easier than this. And this is the third condition where our is like learning rate is too high. So here, when we like subtract the weight, it goes to here. Then we increase the weight, it goes to here. Then we subtract the weight, it goes here. So it just go like this, and this will take much more and many much more epoch than this one and this one to reach the optimal state. So for is like making a right optimizer, we have to select the right optimizer and right learning rate also. Okay, so now let's see some commonly used optimizer. Okay, so these are the four optimizers which you will use. First one is HGD or Scottish gradient descent. So this is a very basic one, and generally we use this, but it is good for large data or like where we need a it's like stable learning. And there is some is HGD with moment. So momentum is a add-on of HGD. In this we have a momentum variable where it increase the is increase the conversion speed and escape the local minima. So what is local minima? Here, if we are going like if graph is like this, okay, imagine this, it is like this, so it can stop here. But when we have a momentum, then it will search like it will search where is the global minima, like where is the deepest point. So it will not stuck if the graph is like to use. So then RMSprop, we use it for, it's like RNN and time series problem basically. So it's adapt the learning rate parameter, and it's like of course for non-stationary object, like in RNN and time series, they're continuously series of network. So it's work more better in RNN and time series. Adjustable momentum goes good with CNN and large scale deep learning. Okay, so these are something. And most common optimizer which we will use is Adam. So it combined the RMSprop and SGD with momentum, and it's like it's the most optimal thing which we will use. Okay, so we are not going to depth that what is SGD, SGD momentum, RMSprop, and Adam. We will make a complete different videos on these topics, as it would take like 10 to 15 minutes for each topic. But in this video, the main motive was to teach you what is like optimizer, how it works. So optimizer just reduce the loss function using gradient descent. Gradient descent is just a curve which try to is like give you the minimal weight point, and the learning rate is the rate by which we increase or decrease the weight. So I think you will have a good understanding of what is optimizer, what is learning rate, and what is gradient descent. So for this video, it's like that's it, and we will meet you in next video.